reading the books and seeing the objects and understanding and asking, and it's a trial and error, and is some feedback is there. The based on that we are learning. So the same thing we are actually biomimicked to using technologies. That is called actually neural network. The neural network in brain we have some neural lines that paths there and some tissues and some formulas there. But actually in technical perspective, in the terms of computer, it is actually in point that can hold some number. It's a number at maybe 1 or maybe point 0.1 maybe or point 0.2 0.5. That range is between the 0 and the 1. That's all. Okay, so come to the LLM. LLM is also a neural network architecture. They're following some neural network architecture, but the basic building block of a LLM is called transformers. Okay, so the next question is that what is a transformer? Transformer is nothing but it is another type of a neural network architectures. I think we are already familiar with the tremendous type of neural networks such as CNN, RNN, and ANN, and also some convolutionals and some pooling is there. So many things is there. So the transformer is another type of a neural network. It is exactly derived from that's called RNN. So the recurrent neural network. I think you are already familiar with the recurring neural networks. Like that, the recurring neural network is normal it's compared to the traditional neural networks at ANN. The ANN has only for just for learning and some forward propagation and backward propagation only. And that is means we can some examples. So you are learning things, but you are only learning for an exam. Say suppose someone exam is happening, so we are giving a textbook and we are studying the 2 or 3 4 modules, and the modules is only using for that exam. Nothing is left. But what happened that when you are studying a point or particular things or particular point, and you are thinking about like that, okay, this is happening how and where I can get it from. So we are again giving a feedback what we learned from. That is actually like a recurring neural network. Okay, understand, right? So the neural network is just going a one word forward propagation, but in RNN we are using a forward plus a recurring recursion. That means we are getting an output, and based on output we are again fed back to the input, so we will get the more clarity or more idea. This was the recurrent neural network. That is actually the recurrent neural network actually built for the time series analysis, some the complex analysis in machine learning part. But that is not actually part of the LLM. Why? Because I will tell you that. So the last language model, we understood that the names are just the language. Language in the sense nothing but it is the data type is some words and sentence, phrase, verbs, adjective, everything is there. So taking like that, so considering one book around 200 pages, you can assume that how much number of characters that present inside that book. So consisting a data like the data, it is very huge. And the relations, say suppose we are doing with some numerical data like that one. So say suppose some time series, and you are getting some sales data from one companies that around 10 years, then you can clearly predict that how that sales data going, because it has a tremendous trend, and it has a valuable output like that, how it is like that, that how it is impacting the result of that company. But for the text data or in character data, we cannot do that. Why? Because it is unstructured data. Like that, we already know that the basic set the basic step of a machine learning to train this data based on two sets, like that, right? The train set and test set. But my question is that anyone's know how we can define a text data like a training set or testing set or X train or Y train. We cannot do that actually for this life of text data. Why? Because in text data we cannot predict what is X
Sir,
and what
sorry
is Y.
for the interruption. Sir, can you please turn on your video for a second so that we can take some screenshots for the proof?
Okay, can you give me sometimes? Currently, give me sometimes. Then I will open the camera. Is it
Okay.
possible?
Okay, sir. Okay. Thank you.
Sure, sure. Okay, fine. So can I continue, right?
Sir, we can.
Okay, fine. So actually, I'm talking about the training and the splitting of the data for the that neural network training purpose. For text data, we cannot do that actually. Why? Because the data is so complex, we cannot identify a direct or indirect relation between the data. Correct. So that was the first point to identify, like keep in mind to dealing or training with the LLM models. Okay, so we know that today in this industry we have a lot of model like Llama, GPT, Gemini. You will everyone's know like LLM is going to capture the entire world today. So every part of our industries or in daily life we are meeting X or Y person like a type of LLMs day by day. Okay, so that was the introduction to the LLM. So we are going to that. So we are already covered what is the part of how the neural network is working and what is a neuron. I already told that the basic building block of a neural network is neuron. That neuron is holding just a number. That's all. Okay. Okay. So we are going to the deeper, like the basic building block of a LLM, which is called a transforms. The name suggests that we know that transformer. This transformer is not from the electrical appliances that convert the voltage to the higher or lower voltage. That is not like that exactly here. But the name suggests some similarity with that. The transformer is like that. So it's a black box. Okay, we don't know exactly what happened inside, but we will get some data, we will get some output. How it is getting, so the transformer is converting that exact text data to some mathematical formation, and after mathematical formation they will calculate something else. The based on something else we will get the clarity of data. That is exactly. So when you're going to the ChatGPT and asking like that, and how we can plan a trip to somewhere else, and how the ChatGPT is understanding, anyone understand like how it is actually is working. Okay, so the transformers actually it is also a neural network based architecture, and it is a basic building block of LLM. And whatever LLM we are showing today in today world, like LLM like ChatGPT, BERT, Llamas, and even is LM 3v2 and the latest one, and it's every LLM models, and we are using this transformer architecture. So this is the actual and the architecture of a simple architecture of a transformer. The transformer has a two input like things is that they have a one decoder, and one is that the thing is that say suppose like that. So it is encoded entity, and we are giving some data, and the data is like that is encoded. After encoding they are doing some process, and after that it will be decoded to the human languages. That was the exact the function of a transformer. And this detailed architecture, we can see that so much flows is involved in that. So it is not a simple one, and it has some complexity. But we will what this session what I planned that using without using too much of mathematics and too much of coding skills, just we are going to try to understand what is exactly LLM and how it's working, and what is the basic things, and how we can explain to someone else how this ChatGPTs work. That is the only intention to this session from my side. Okay, so talking about again transformers. The transformers has multi layers, or it has a single layer. What architecture we can suggest that, or we can use that. Actually, what is transformer doing that? I will do with an example. Okay, it's just like that. We will going to create a small LLM, like not in the coding level, but we will understand how it is actually is working. Okay, so like that, when you're going to your ChatGPT or any LLM interfaces, and you are going to search type like that, help to plan vacation in Kerala. So what is exactly ChatGPT do, or the LLM will do? LLM will just feed the entire sentence, and what happened that entire sentence, and he suggests what is the possible next word. Again, this word is again fed back to the system, and again predict what is the possible next word, and again it's fed back to the system, and again it suggests the next possible word. This is the exact flow how the ChatGPT or LLM is doing. Okay, so just go to any LLM or ChatGPT or in Llama, like a Copilot, anywhere you can just search it with this word, and you will get the exactly same thing. So it is not a rocket science. Just fitting that sentence, and looking for the exact the possible next word, and that word including, then again fed back to systems, and again predicting the next possible word. This process is continuous, and we will get an entire sentence. That is actually the chat GPT is working. So the next thing that we are going to do, that how and what is the word embedding, like this is the basic, and the other one, and we need to understand for before going to the LLM, is called word embedding. So as the name suggests that I think you can understand word embedding. So we will plan this data, we will playing with the data like texts, word, sentence. But the thing is that the word or the letter or the language or sentence, that is completely defined by human minds only, correct? So we humans, and we build the entire world, like that is technologies, and the part of that civilization, we are building these languages for communications only. So it is a completely human thing. So how a system, or other than like a hardware, a software can understand that? That was a major concerns on the scientists or developers who building this kind of the complex technologies. So everything, so we say that the ribbons and the like that the definition of the word is running to the mathematics, someone say like that. The exact way that what we can do, that we need to convert, and we need to formulate or metricize this text data to a mathematical formulation. Then the computer or any program can understand that. That is the first step, that for the building a LLM, it's the first step to the embedding the word. And what do you mean by embedding in the word? Like that, we can say that, so we contextually we are taking on word, that king, you can see that the king is a word actually. So how we can define it, the king? So say suppose the king has authority to anything, and king is so much rich, and king has palace, and king has queen, and something like that. Every, so we can identify, like we can formulate so many characteristics in, like in programming language, we are called, it's called oops, object oriented programming. Actually we are defining some classes, or we can define some dictionaries based on how the king can be represented. Okay, so king. So what I can do, that I just listed some property or parameters, and how I can represent the king word. So authority, and has tail, and rich, and gender. You can see that has tail is nothing no addiction with related to this situation, but just for understanding. So I'm taking some random parameter, and the random parameter, how this related to this thing, actually the authority. Okay, so just like that, what I do, that the based on the explanation of that word, I will make some parameters, that authority, and has tail, and race, the gender. I just list down that parameter and give some values. Okay, so what is that actually? So I think we know that how we represent things is in the mathematics. So we are going to hyperplane or a semiconductor plane. You know that in two-dimensional or three-dimensional, how we represent the points is here. It's called vectors actually. The same methodology we are using here. So we are just converting to that, the enter that the parameters into the vectors. You can just see that I'm just taking that vectors into in the formal vector, and that vector, we have some representation of that word. The same thing I'm just building for the queen also. So you can see that the word king has some vectors ahead there, the queen has some vector is there. So what is exactly this meaning? So I identify some parameters, so defining some situations or words. So here is the king and queen, and I represented, I'm taking some parameters, and the parameter, I'm giving some values based on my experience. Okay, so it has saying that the gender is in gender high. I am taking the gender for male is -1, the female is 1, and his tail has 1 is 0, and authority is 0. Like the same way that I taken some parameter, and I put it the value based on my understanding. So you can see that. So I based on that, I created one table here, and just for your reference. So here, for I'm taking some events, some parameter, and some object, I taking the x-axis, and that the y-axis I'm taking some parameter. You can see that authority is there, even he is there, has tail, rich, gender, some possible parameter I taken here. So object for battle is there, house, king, man, queen, women. You can see that so many parameter, and what's the value. So you can see that for king, the authority value is what? Definitely the king has an authority, correct? And the host, and considering host has less authority. We can say that the king has host, so the host has some kind of like authority there. So I will just put a very low value. Okay, king. And man is a common man, common hands compared to the king. The man has very less authority. The queen is equal to king, so we are here to go for equality. So the king and queen have the same responsibility and the same authority. And the woman, it's a common woman, is compared to the queen, very less authority in that environment, correct? So it's even, it's authority and authority basis we classified. And for even basis, battle and the horse, the king. The battle means an event, not an object. So I just given a flag that is even flag is one. That means battle is an event, not for authority, not has authority, as it does not tail, it does not reach, it's not has him like that. The way we will formulate the entire matrices, we can understand what we provide that it is called the word matrix, or we can speak without words using mathematical formulations. Okay, so the thing is that what we can do that with this. So what is the thing and what is the use of this that? So here is the magic is happen. So that is the what is I am saying before. We can do everything based on mathematics formulation. So here, what I can do that I'm just clearing, doing a just a common like addition mechanism using the vectors. You can see that take the king vector from this matrix. You can see the king vector is 1 0 0 1 minus 1, and minus the man vector here 0.200 zero 0.3 minus 1, and plus the woman. Okay, that is equal to the queen. Okay, think about the reality. So the king is some authority person, and we are minusing the man. We will get a common matrix. Then adding the common matrix, we will get a queen. So this is how a, a mathematical model predict that based on the data, especially for the vector embedding data. Okay, I think you understand. Any doubts you have for these calculations of how this vector embeddings work? Tell me, ask me now. Anything? Okay. Fine. I think hope you understood. So this is a basic building block of LLM. So this is how the vector embedding is work, and based on the even vectors, we can understand or we can predict that the based on the correlation, the vector embedding and this calculation is actually the correlation. So I will tell you that. So there's a common question is there. So how I can know? I need to minus the man from king and plus the woman to get the queen. That is the logic here. So for that, this is called the pattern. So we identify the patterns from what the data we provided. That pattern, based on pattern, we can derive some formulas. That is a human thing. But how this is handled by the LLM? And here we are playing with the neural network. Neural network has a capability to identify this kind of patterns and this kind of formulas. They will understand the data and they will predict it. So here we can see that the king minus man plus woman is equal to queen. That is not rocket science. It is just that is a matrix addition, and like that the dot producting, add producting, everything whatever we learn from the normal textbooks, that should be updated here. Okay, so the next thing is that, so I can see that I'm basically I'm taking one word for 1 2 3 4 5 parameter. Actually, you know that for ChatGPT or any other LLM has, any Google LLM has 300 dimensions, like 300 or 400 20 100, like more than parameters they're taking. So taking this parameter for, I'm taking the authority, even, tail, rich, gender is a parameters. So I'm taking 10 parameter. The description of the event in a vector model, it's very clear. So taking 10 or 100 or 1000, 10,000 on crowd, the based on the data, or based on your hardware computation, it is we can decide it. So the basically the parameter they are actually the actual scenario for LLM. They are training based on the 3,000, 10,000, and based this large value for they are using actually for one particular parameter, like one particular word. So they has that that is called corpus. Actually it is called corpus. That corpus has a large volume of data, that where the data is actually getting, they're getting from internet. We know that we have the internet, we have all the data. This kind of all data, the some spiders is there, that spiders is calling this entire data, and data should be converted to this kind of some vectors and some kind of mathematical formulation. The based on that, they're training the model, identify the patterns, and the pattern should be given as a result. This is the LLM how works. Actually, I will tell you one more interesting fact, that how this is mathematical representations work actually. So here I am taking the five, like say suppose five parameter. Say so we know that vector, like the matrix representation is a actually is a dimensional representation. So here I'm representing the five thing. It should be five dimension. So the actual scenario, actually we know, we can say that the actual scenario the LLM using 300 to 400 dimensions, and not saying that parameter, I'm saying dimensions. Okay, you can just imagine that. You can just imagine how we can draw that two dimensional, one dimension, two dimension, three dimension. After that, four dimension, we cannot draw that, right? We can just imagine how four dimension is working, and go to the fifth dimension, it is not possible. And then go to the sixth or tenth. Then the LLM and other neural networks or like LLM models train on 300 plus dimensions. That means the direction and the possibility or the prediction level is so high actually. So understanding like that, say suppose our king, that particular one vector I'm taking as a three-dimensional, you can see that where is the king is positioning. Okay, like the values of vector we are taking in the axes, and we are drawing some lines to that point. We will entirely tracking that exact position of that king. So I will show you that how it is working actually. So I'm giving one three-dimensional way. He's a king. So and this is the queen. It should be there, but considering the horse, it should be somewhere else. Okay, you understand that. So the distance between this and distance between this is the, that is called is variance. That is exactly predictive relationship. So here we can see that in our cases the horse and the king and queen is there. And also we can just say that man and woman should be like this here. So this is the actual representation. The based on the similarity, and we can calculate the exact variance, what is happened to there, and we can predict the exact the way and the exact output what we are required actually. So this is how the vectors are represented here. So here you can see that the king and queen, there's some that this is the directions, and that direction is actually called the variance. The based on that variance we will understand, or we can predict the next thing. And the prediction of next thing, that is I show here. The based on this calculation we will get the next vector on that. This is the basic things. And we will basically we are using some that word vector or glove is that is a like using tools. Many tools we are using nowadays is for this kind of things, but this is the famous some tools actually. So like I'm explained at how the static the thing is called static embedding. So why is called static embedding, I will tell you that. So here I'm like okay, so basic things. Okay, say suppose I'm like that. Just I'm writing one sentence called. Okay, say suppose the train is running on track. Okay, okay. So say suppose I can see that this is sentence. Okay, I have one, two, three, four, five, six word is there. So I just split that the train is running on track. Okay, say suppose I'm giving some vectors. Okay, so okay, say suppose some static vectors is point 0.3 here and some point 0.06 is here. Is as less point 0.02 is there, and it has more polarities, that is point 0.7, and on is also less point 0.02, and track is around 0.67. Okay, here I'm considering the word is track. Okay, in this track, actually how the track is like related to the context actually. So I'm having the all static vectors here, and based on static vectors I'm giving some predictions, or I'm giving some calculations like a prediction. But what happened actually, so we are just embedded the things like the track only, that basically the track may be railway track or some other track, and is running maybe somewhere else. So we am not looking the context. I'm generally I'm classified. I'm vectorized these that static parameter. So what is the disadvantage of this? The exactly point is that when we are doing a static or normal vector embedding, this should be not capture the context of that word. So here, say suppose that the train is running on track. So I say suppose I am having another word. My sentence is my package. My package is late. Okay, help me to track. Okay, you can understand that the track the word we have the boss situation. So here the same track I am having that vector embed value, that is static value, this 0.67. Okay, what is the result here? So the train is running on track. My package is late. Help me to track. So the word is different, but the context is so different. So sorry, the word is same, but the context is different. So the train is running on track. That meaning the train is on the track. My package is late. Help me to track. So the word is same, but the context is different. So the same, but in our embedding stage, the track, the embedding point of or vector point of the track word is same for the both scenarios. So this should be a difficult for to understand in the context, and based on context we need to predict the next thing, or we need to match the anything. Say suppose you are saying that say suppose the chat gpt or any llm is based on a static embedding trained based on static embedding. So the both situation, the model is taking the word track in a same manner, the same weightage. That will lead to a wrong prediction because the context is not aware by the LLM. That is the limitation of actually the static embedding. So the word meaning, the word meaning actually, it is depend on the context where we are actually placed that. So for static embedding, that is not possible. Okay, so the next one is how we need to overcome this situation. That is the next question. For that, we are using the contextual embedding. Okay, so actually, what is a contextual embedding? Contextual embedding is actually called, say suppose this like this sentence. I made a sweet dish called. Okay, I'm just here writing this for like I made a rice dish called. Okay, so what is the next word? Anyone predict the possible words is we can predict for the next sentence? It's like maybe idli. Okay, no idea. Is idli, or it's say some Mexican rice maybe. Okay, it's an American rice or Indian biryani. Too much. Like we don't know exactly. So there's a possibilities here. So the same sentence, I made a rice called. It may be something else, Italy or Mexican rice. Anything is there. So if I'm changing that word, I I made a dish, but I am just putting one simple word here, Indian. So then it should be going to the specific area. It should not for the Mexican or American like cuisines. Only for Indian, it should be idli or in biryani or in like in any food, any rice food. So this is actually a like contextual embedding. So we need to understand the context. The based on context, we need to predict the next word. But based on the context, we need to match what is the thing we have. So I will explain you that ChatGPT or any LLM not creating a new word. Don't think like that. So they don't know how to create or write a new word. What they're doing like that, they are just creating the vectors and they are doing some formulation, and they using that vector, they are matching what is the possible value of that vector in the database. That is only. So this is the actually that is the contextual like embedding is work. So say suppose this sentence, you can say that. So just read the sentence. You can say that, bro, we will get the restaurant for you, like after 20 minutes they will rise in an Indian restaurant. Okay. And two friends are going to eat something. So one is like to do one some Western foods, and one is like Indian foods. So here you can see that the like Dovels love dosha, doka and mild based, and Bhavin on the other hand likes pasta and soups and well, they both went to the dinner, and Bhavin said, "Bro, we will go to the restaurant." Like after 20 minutes drive, they were in an Indian restaurant. Okay, so here I'm just going to change the restaurant you like I. What is the prediction is going to change? It should be some Italian restaurant. Why? Because the context is changed. So the context is completely changed. The only one word I changed, the context is changed. So the prediction of what we need to predict is completely changed. So you understand that the embedding of the vectors and the word should be related to the context of that happened. Where is the what is happening and what is the context? It should depend on the context. So we need to go with a contextual uh, embedding. So again, I'm going to the architecture of the that transformers here. In this transformers, I already told that we have a two layers called input embedding and output embedding. So what is embedding is work like that. So we will feed some data to the transformers architecture. The transformer, what we do, transformers completely understand the context, and based on context, they will create a mathematical formulation. That formulation creates some vector maps to the words or context that they have already stored in the databases, and based on that keys, they will predict the entire situation. So I know you will not understand what I'm talking right now, but this is the thing. But this should be solved within some 1.5 minutes. Like we will go to there actually what is exactly happening inside a LLM model. Okay, so actually, we know that the general LLM models BERT and GPT. Why I'm just writing that BERT and GPT? So in this complete scope of section, we are going to cover only GPT-3 and the BERT model. That is the major idea that is focusing on this. Okay, so the next thing we are going to the vocabulary thing. Okay, I will show some things and how this is working. So the same example, but I can do that the same thing. So the train turning track, I'm taking the same thing. So here I'm doing this. Okay, so the vocabulary in the sense. Okay, so we know that what is exactly vocabulary. Vocabulary is nothing but we have that the group or that complete word mapping we have. So vocabulary in the sense we have the whole vocabulary, right? The same name we are indicating that. So the train is running on a track. So what I do that? So I'm going to do a some positional and as a contractual embedding to here. So I will the calculation part I will show you that some. So basically I'm taking some random value here. So the I get some for three-dimensional structures, I'm getting some three-digit value like zero point 0.6, zero point 0.4, zero point 0.3, and zero point 0.4. Okay, and the train has something. Okay, the is a very less very less used word, like that is not impacting the entire sentence. So I'm keeping less actually. So point two itself. But the train is actual word, so the train has so much, but it's like difference is high, so zero point 0.6, that zero point 0.7 and zero point 0.8 is there. And is also the same thing I'm putting here. Okay, and this running is also that same thing I'm putting here. Okay, on is also the same, is less, and this is also like this. So it is a random calculation actually. Why it is so calculated? So the thing is that the track this word actually is depend on the previous word. Okay, so the train is running on this word actually contributed based on the previous the series of words. That is a contextual embedding's basic principle. Okay, so in this method, if you are going to do a vectorization, you should consider the entire thing. So that is why that is called three-dimensional or five-dimensional actually. So the thing is that the track vector is predicted based on how the train, the is, the running and on, how the contribution is happening to the prediction of this word. Actually, this is actual that the calculation of that. The calculation is somehow some has some mathematical formulation that you can check in the internet or any other paper, how these vectors is calculated. Based on some standardization formula is there. So the next thing is that we have calculated that the dependency, nothing but that we are doing some byte pair and some BP algorithms performing on this sentence, and that algorithm is capable to identify the priority and the dependency on the that words to the next, and they will track it this calculation. So we will get that is called that contextual vectors. And the next one is we know that in languages the position of the word is very important, correct? So the train the it's not possible, correct? So this should be the position of that word is also very important. So we will also go, this is called contextual parameters, and we will just go to the positional parameter. So what I can do that, I will again calculate a positional parameter for that, for same thing for point 0.6, point 0.5, point 0.3, point 0.4, and point 0.3, say like that only. So the thing is, I'm just randomly giving this calculation. Okay, and here the point 0.2, point 0.4, and point 0.6, just like that. It is a also random calculation. So based on, we will get what two vector is there. First vector is a contextual vector. The contextual vector is nothing but this is the dependency, or how the track is depend on word, the running word is, and train the same way it is overlapping. How that the is depending on train, the is depending on is, the is depending on running, the is depending on, and that is depending on track. The same thing, the every formation, like every possible method we are calculating, and we are just derive this matrices the same way, the exact same way we are calculating what is the position of the word. Actually, the has a position, and that position has a argument, and that argument has a vector value. So the same way, the train we are calculating the positional value, the running is a positional value, everything we are calculating the positional value. So what is the result is that we are just going to add these two vectors. Okay, so we are going to add these vectors. I'm resulting some new vectors of zero point 0.5, again point 0.6, and 0.7, like that. Okay, simple. No rocket science, just we are adding this vector, and I'm putting for same value for this reference. So we have a contextual parameter, contextual vectors, and based on the contextual vector we have what we have that positional vectors, and adding these two vectors we will get exact value for that contextual embedding. So this is the resultant embedding. This already embedded two parameter. One is the context and the relationship between the next verses and the position of that word. So based on this, we will get a clear idea and how this one word is related to this. So in this scenario, what we can do that we will understand when we are changing on I, what the LLM will do. The LLM will do completely on these two calculations based on the I. They will do the relation with the I with the double laws, everything. They will tremendous simultaneously calculate it, and based on that vector they will identify the maximum possible thing what is need to predict it here. Okay, so that is actually is code sorry. I'm actually going to the vocabulary. So the vocabulary is like nothing but, so we when we are going to train a data set, say suppose this is a data set. Okay, what we have, the train is running, so we are changing, we are calculating these this many vector. This is the vectors what we are capturing, and this matrix is called the vocabulary. So this is the mastermind, and this is the heart of LLM. So based on this, not just think about this 2 3 parameter. You just imagine that I already told that it's 300 dimensions or 20 to 30,000 parameters. It is a huge value, and based on that, they will maintaining a data set. Actually it's a database. In that database, these kind of the what the data present in the internet, they will know the exact embedding and vectors parameters in the how. So everything is keeping in a database, and this is called actual vocabulary. I think you understand that. Okay. So the exact calculation, like this is how actually we are calculating that matrices, like for the contextual parameterization and sequence vectoring. So if we are okay, if we are getting for a word, we will get a complete data set, complete matrix called WE. WE is a magical matrix. Actually, that magic matrix has all the data sets values based on the position, contextual relation, everything. Okay, so currently I'm going forward. Any doubts we have currently? Anything you need to understand? Any area? Just focus on like any questions. Okay, I think hope you're getting clarity on how the LLM is working. So I'm going to I'm not going to the deeper level. I'm just only get the random values and random numbers and just saying that conceptually. Okay, fine. Okay, the next very important thing is that what is attention. So when the LLM, I don't know, you remember that when I think 2019 or 2018, at that time, Google released a wonderful paper is called All Need an Attention. Just search in the Google, there's an article or a paper, white paper called from Google, All Need Attention. Attention in the sense, the same thing what we are explained it before. So attention in the sense, just see here, so just look this word actually. So you and Indian, these two words is just changes. The entire context of this word or sentence is changes. So what is actually happening? So the you and Indian and all the word, exact every words and every character in this particular sentence actually need a attention. So we know that attention based neural network, I don't know, someone maybe know that. I think maybe already you will get a clarity or session on that attention based neural network. Actually, attention in the sense, attention is a mechanism help the model focus on most relevant part of the input. Okay, so the most relevant part of an input, and how the most relevant part of input can be know that, and it assigns a different weight based on the important weight to the each other. So this is the way the neural network or LLM to understand. I already know that how that this vector is calculated. So how the vector is calculated, how the LLM is just know this is the exact point and this is the value, and this running is most important and train is important. Is not a word, it is just like the connecting the words. There is an article, and these kind of things is learned from attention based neural network training. Actually, it's a new technique or new technology. It is called attention based neural network technology. The same thing we can see that the entire context is focused on some words. that words need to be found from the neural networks. So it is called attention based. So how it should be worked. So that is we are going to say here. This is a three symbol word: query, key, and value. So the query, key, and value, these three things is only for the three. If you understand three words, you can understand completely LLM. So this is the way, and this is the heart of an LLM: the query, key, and value. I will say that what is exactly query, key, and value. Say suppose you are going to a okay. Say suppose you are going to a library, okay, and you are asking like that. So I need a book for to get to know about LLM. Okay, so you have query with there. So you have a query. The query is that you need a book. That book should contain what? The book should contain the context of LLM and LLM, everything you need to understand. So that is your query. Okay. So next one is, so what is the key here? So if you are telling to that librarian what he understand. Okay, you need the book related to LLM. So what he do that he will check the row and he will check the book and he will understand which rack is that and go to there and the shelf and he will get the book and give it to you. So the data related to the shelf, the position of that book, it is actually called the key. The next one is the value. What is a value? Value is that using the query, you will get the key. The key retrieve the value what you're looking for. So here the value is the content of that book. Actually, in that book they have the most terminologies and architectures using the LLM. That is actually your value. So you are valuing that. So you need that. You just coding that. You just coding means you will get some keys. The based on the keys, they will find the thing and you will get it like a value. Okay, this is the exact thing. So here think like that. Okay, so you are coding something to the chat gpt or in LLM. So what is actually chat gpt will do? Chat gpt will do some keys based on a query, and the query, the finding the query, the key has some so much of the methods. That is, we are already saying that how this vector embeddings work. And based on embedding and vectorization, and one more other thing is called byte pairing. We will go to that level in the coming sessions. And based on that, they will find some code, then keys. And based on keys, they will get some other values. That is, other thing is called a value. The value in the sense, and they are relating that key to the exact content what you are expecting. Okay, that key, that value you will retrieve as a output. Okay, this is the thing. So actually, what is that? This is the simple equation: wq dot e7 equal to q7. So I will explain to you how it is working. So the thing is that when you are going to train a LLM model, so you can see that you know about that how the machine learning is work. It has a supervised learning and unsupervised machine learning. So many is learning, so many type of machine learning is there, correct? So so suppose you have some data sets. Say suppose you have some cats, some dogs images there, so you need to classify that. So you will go with a supervised machine learning. So you will train a CNN model and feed that data to that model. You will get that predicted value. Is a cat or dog? Okay, say suppose you have some tremendous numerical values. Say suppose you are working in a oil machinery station, and oil is coming to the different flows, and you need to understand which flow will threshold it, and that kind of calculation you will go with super unsupervised machine learning. So you will go for a K means or K means algorithms, and you will predict that. But in that all situation, you know what is the data and what you need to output. So for the cat cases, for you have the data set of cat and you data set of that cat and dogs, and you will know the what is output we are going to achieve. So in that, the output is we need to predict the data. The given image is based on a cat right? Talk. That's all. Simple. And based on like the oil machinery data, you will understand what is the output, what you need to do that. So based on threshold values, we need to we need to get the valve pressure, and based on valve pressure, we need to understand the oil is going to leak or the oil is getting something else, and so much of this there. So we are using classification algorithms anywhere. So every part we will understand what is the output. But for LLM, we don't know what is output. So we will, what is the problem is that we are writing, or we are taking one paper for that, same IEEE paper. So you don't exactly don't know what is exactly that. Not for human, for computer architecture level, they don't understand. So what is that? So for LLM to understand this kind of embedding should be there. So the point is that there is no X and Y. So there is no X and Y. We cannot provide that. So the finding, but you understand, we know that for a neural network architecture, we need a backward propagation and feedbacking. We should give a training set, and based on training set, we should train the model, and the model should be predicted some value. In for that, we need a training set and testing set, validation also. So for this text data, who will do that? So the interesting part, that is we are introduced the transformer. The transformer has two part, the encoder and decoder. So here, what is the thing is that the finding the X and Y. I am repeating the finding the X and Y, the training and validation set of from a text data, it's from LLM. So when I'm giving to the data to the LLM first do to split the data into train and test set. But here the form is different. So simply what I can say that, so you are building a LLM for say suppose TocH is building one LLM for their policies. They have so much of policies in their internally maintaining. So they have some courses they're offering. Say suppose they're planning to do a chatbot or LLM to train the data based on the courses that were provided, so they can easily just publish that model, so anyone from the world they can achieve that, just query that what is the courses they're providing to the chatbot, they will return. So in this data, in this model, in this situation, what is the input to that model? It is the complete policies, the complete course details, the complete things based on the context. So if the context is fit to a LLM model, the LLM model, what we do, LLM model, that complete data will take up and say that, okay, I will take care and give some minute. What he do that, he just analyze the data and split it to the three matrices. That is, one is the value matrices, one is the key matrices, one is the Fourier matrices. So you can see that here I'm just written this equation WQ dot E equal to Q7. You know the simple math. Then understanding the Q and the value and the query, we will get any other. Okay, say suppose we have the normal machine learning, we are going to create the data set based on X train, Y train, we are creating an X and Y. But here, that entire model is converting to that plain text data to some matrices level. That is called value matrices and key matrices. And one more thing is called query matrices. This is the main logic happen on this that. So I will tell you one more interesting thing. So based on how it is, so say suppose I have a query and GPT is getting that key, and how they know that which is relevant to the data. So I will explain one more situation like that. Say suppose you are all like I think you are working professionals and in various sectors. Maybe suppose one manager, and we have a team called three people, and one manager is come to that team and said that it's okay, we need to create a LLM model, and for particular for this. Okay, so this that four people is there. One people is good with computer science, that is fine, and one thing is guy with very good in philosophy. and one is very good in mathematics. Okay, so the first case say that okay, I know the computer science and I know the how the training is and the neural network is working and I will train the model. Okay, the second guy will say, I know the philosophy, so completely I know the philosophy. And third guy will say that okay, I need the mathematics, so how can I can formulate the mathematics side of this LLM. Okay, so the manager is just evaluating the three inputs. Okay, the based on this input, we know that the philosophy is not related to LLM. So that input, that value is not needed that. Okay, so to and the computer science and the mathematics need for this LLM methodology. So they will select that. So here we will just rank the values for the guy that is a lower value. The philosophy value have the like sorry that mathematics and computer science have the lower higher value, and the mathematics value guy have the lower sorry that philosophy guy have the lower value. So it is a simple thing, correct? So they can understand, they will relate is like that, which is interconnected and which is common, it is closely connected. So the point is and the question is that how that can be know that. So we can as a human we can understand that, but how the machine learning or LLM is just identifying which value is more closely to the key, that is called cosine similarity. So I think a lot of will know about the cosine similarities like that. It has a pure mathematics. What is that? We have two vectors, and that two vectors has the tangent and the slope of the slope of the that individual parameters. Say suppose I have one matrix called one and two and three and five. Okay, and point zero one. Sorry, one and three and four or six. Say suppose here four and six and eight. Okay, what is a cosine similarity here? Cosine similarity in the sense we are just taking the dot product and give a tangent for that. So what will return that? The return is getting, we will get the probability distribution of how the one vector is related to the next vector. Say suppose I will simply explain that we have one key one, and we have a value one and value two and value three. So we will okay value four. I will get value four. Okay, so we have this one vector, and I am getting the dot product and tangent for this entire array. One, two, three. I will get to one probability distribution like that, point 0.9 and point 0.6 and point 0.4 and point 0.2. Okay. Say suppose here the same scenario. What is our context is that? So I am asking that I need to create a LLM. So I am creating a LLM. Okay, LLM. So the V1, the value one is that is called that guy mathematics. Okay, the guy to that one is called some that computer guy, and that guy is called philosophy, and one more guy. Okay, he's good cooking. Okay, fine, he's good cooking maybe. Okay, so say we will get the cosine similarities is probability distribution here point and point 6.1. So you can understand that this the key value is one. Every key value is just the number one. The one is more related to this. No, this no. This is pretty much and this. So this completely thing is taken as an output. This is called vector embedding or cosine similarity. So you can just check how the cosine similarities work. It has a lot of derivations and some like mathematical explanations there, but understood that. So you are giving a query. The ChatGPT will take the keys and take the cosine similarity with the database and fetch the probability distribution more closest to one. That's it. So this is a pattern that uses. Okay, so in actual way, what is that? So the thing is like that WQ is a matrix. So WQ is a matrix, and the dot product of that matrix with E7 in the sense that individual words or patterns. Okay, that's equal to that query, that the query. Okay, that is equal to should be, so that's equation. Okay, we will leave that one. So that is equal to that query parameter, that query vector. Sorry, that matrix. So here is the basic things that. So when you are doing a LLM and this the model is trained, once you broken in that model, you will see these three matrices. That's all. So all other playing based on this. So 1 second, I will tell you that this is the data only, but based on this data, what is called, we will get to know some patterns. That we will, for that we will use the normal neural network to train for that things. Okay, and these things is the basic things regarding the LLM and the concept of LLM, and the basic things is what happen inside LLM. So I will again go to the transformer architecture. So this is the transformer architecture, and what we understood that cosine similarities, byte pairing, contextual parameters, that everything is happening inside this guy and this encoder. And what happened that we will get the data, and that data they will completely go to that byte pairing that we will discuss later, the byte pairing, and based on byte pairing they will get to know that contextual parameters and the positional arguments, and based on that we will create a query data, and based on query data they will create them key data, and getting the dot product they will get a value. Simple. This is the beauty, and this is the method, and this is architecture behind the LLM. This is how a LLM is going to work. Okay, and so we are getting the next. Anyone has any doubts? Sorry.
Sir, it's just by an accident. Someone unmuted by themselves by accident.
Okay, fine. Uh, okay, we are going to the next level and the next step, and this interesting part, and we are. I will we will go to the next part, and if anyone, I'm sorry, that's can you please mute that?
I'm sorry, sorry it. Sorry for
Okay,
the inconvenience.
okay, no problem. Okay, fine. So now like anyone has any queries and that mathematical parts and the discussion happening on that LLM, then we will go to the next part. Any doubts, any clarification you needed? Okay, I think we have no much time, so I'm going to the next part.
Sir, sir, before moving to fine tuning LLMs, sir, can we take a screenshot just by presenting a PPT of showing this slide? I mean, the title of this slide.
Yeah, yeah, sure.
Thank you, sir.
Mm, okay, okay, give me 1 minute, okay?
So sorry for the delay. We will make it fast.
Okay, fine. So you want to switch on my camera, correct?
Yes, sir. Can you please switch on your camera?
Okay, fine.
Thank you, sir. So can you just show the first slide of your presentation once more, sir?
Okay, you need a first slide, correct?
Yes, sir. First slide. Thank you for the cooperation, sir.
Okay, fine. Thank you. Can I switch off this camera, correct? Okay, and we are in. Okay, can we start?
Yes,
Hello?
sir. Yes, sir.
Okay, fine. The fine tuning of techniques and tools is okay. Regarding that, I assume that everything is clear for you. That if any doubts and any queries regarding this, you can ask. There is no issues for that. Okay, for the fine tuning. Okay, let me explain what is fine tuning. Okay, frankly, I'm asking that to create a new LLM, it's possible or not. So creating a LLM from the scratch, that is not possible. But the ChatGPT, like that OpenAI and the Google and Microsoft do that. They can do that because they have that more computational power. They have that of resources. They have that of funding. But as a common people for us and me or you guys is to need to build a LLM from scratch. That not possible. Then nowadays that is not possible. Why? Because the consumption of the hardware, the consumption of the data, that consumption of resource is very high for building a LLM from the scratch. So it has a lot of resource investigation, like too much of process is there. So from industry, for our people, what we do that we will take a model that already provided, already trained the large data set, like that Llama or BERT or in GPT-3 or 5. So that we are taking that model, and what we do that we will just train that model based on our data. It is type of a supervised machine learning. So you think is like that. So what you want to do that? If you want to, like, they suppose we are going to the back of that example, like TocH is going to create a policy, and they're keeping a LLM for their policies and their course structures. Even else, the students' data and that 20 to 25 years of data they have, and they will create a like LLM to predict or identify the students and their courses, anything. So what is the action plan of that? So building a data like LLM based on TocH data, that is not possible, because considering LLM parameter, I already took the 300 dimensions and 20 to 30,000 parameters, nothing much. So what we do that we will take a already available model from the market. See, suppose it's a Llama, or is it Gemini, is it nice, or in GPT for what we do that we will take that model and we will fed the data to that model, and we will tuning that model. Okay, we will fed that data to model, and we will just change the behavior of that model based on our data. It is called fine tuning. So fine tuning is also a resource much process and has a lot of GPU compatibility, and also it's required some skill sets. That is called, we need to get to know how the byte pairing is working and how we need to transform the data from the scratch. Okay, I think you understand the scenario is like that, nothing but we need to create a pick a model. So, and based on that model, we need to fed that data, and based on data, we need to change the behavioral of that particular that particular model. So this is called the fine tuning. Okay, so the basic thing is that for the fine tuning is a byte pairing. So I think I don't know how much time is left actually. So I will just go with the line by line. Just what is byte pairing? Byte pairing is nothing but we already know that we already know that how that vector embedding is works and how that contextual parameters work. But before that, that is a textual data again. So what we do that we will recapture and reorganize the data. Say suppose simply I can see that, say suppose hello, I am Abhijith. Okay, fine, that is fine. Okay, so what is a byte pairing is that I'm just splitting these characters. Hello is H and L, sorry, HEL L. Oh, okay. So what I do that I'm just splitting that characters. Okay, then characters, and based on that I will find that. So I already told that this too much of data is coming to that model. That is not good. That is taking too much of time. So what we're doing that we will analyze that data based on the word by word. We split on the white space, and what we do that we will just analyze what is the most common repeatingly elements in that word, in that sentence, and we will just cut all other words and just string that entire sentence with the most repeating elements. Why? Because we will get the context from the data. If they're reducing this unused verses, and using that we will reduce that number of parameters and we will get the clarity of the context. Okay, I will show with an example. So here you can see that I think my notepad is visible to you. You can see that. So one one file I'm copy here. So this is the one data set that I'm going to train here. So this is my first task, that part of LLM training process. The task number one, that to test different method tokenization process including BPE. It's a tokenization. So what do you mean by token? Token is nothing but token, and just I'm giving one data and converting to a data into an encrypted model. That is the thing, that is the tokenization. So here, so file content, so this is a sentence I'm going to use for byte pairing. Actually this is the training data set in LLM we are called a corpus. It is called the corpus thing. So we are letting the corpus, and so what I'm going to use that I'm using one pre-trained model here, NLTK, and based on that I'm like downloading the data. So you can see that the model is downloaded, and what I do that I'm just tokenize this word. You can see that this is my first task portfolio and process is a sentence. So what I do that I'm just tokenization. You can see that how the sentence is transferred. This is my first task. So I'm just splitting that data. So again, what I can do that I can do this with sentence. Okay, the sentence I'm just doing the sentence conversion. So this complete data has two sentence. I just converted that two sentence. Okay, so again I can do that with a character, like character is tokenization. So I'm just split it based on the character level. The entire sentence I just split on the character level. Okay, and also we can see that, so this character level we will byte pairing. So identify the repeating characters and we will just formulate that and remove that unused characters. Then frequency one. So the vocabulary size is 100. So what I need that I need to get the maximum possible values, the possible words from this enter that sentence is what I provided for training purposes. So, okay, so here I can see that vocabulary size is 100. So that means I need 100 data points from this sentence, and frequency is one time I just recurringly train for that actually. So this actual purpose, this is in real time cases, it should be 10,000 or 20,000, maybe a larger number, and based on what you are looking for actually. So here I am going to that byte pair, and this is the tokens. This is a token. You can see that this is my first, like based on that they will that classify the most repeating words into a token. Okay, so based on the token is some encrypted data. So based on token, I can achieve that. I can reconstruct the word back, and based on that, the character token. Based on the character token, I will can I can reconstruct the word back, because we have the character arrays there, and we have that sentence arrays there, word arrays there, and this array they can be converted to the back. Also, that is also possible. So why the tokenization is happen? Because when you are feeding the data to the LLM for fine tuning, this is an important thing. This is a very major step that we need to do. This is a byte pairing. So so they have some more things is, but due to time limitation, I'm going to a sample a very simple fine tuning process that I can we can you can do with your knowledge base. That is simple one. So here, okay, I'm just reconnecting the collab actually. So here you can see that. So how I can fine tuning a LLM model. So the fine tuning also a large process, and you can see that this is the exact because it needs some more computational and the more GPU powers, and for the fine tuning and training purpose. And currently that is not available for now, because real time we are using some supercomputers and some other vendors. We are training that maybe basically for LLM and normal LLMs, when you're fine tuning, it should be taking a normal in GPU percentage. It should taken 12 to 14 hours for training. That is a huge data level is there. So the training or the complete training of LLM currently in a demo, that is not possible. So what I do that, I'm just giving a simple example how a fine tuning is working. Okay, so you can see that here I'm just insert some libraries from Python. Actually, it's all that SQL, and you know that how the SQL is work. From the cosine, you see that something is says, okay, the cosine similarity. So we already know that what is cosine similarity actually. So based on cosine similarity, we can match the values and keys, and we will get the predicted output. Okay, so because of this, we can do a complete LLM. This basic building block of LLM is transformer. Insert transformer, we can see that cosine similarity and these things is also. So just wait for loading that model. Okay, that the model is loaded, and next thing I just going to use that model, that mini LM L6V2. This is a model from Google. It is open source model. You can run it to your computer, but you will just need a good GP power. Then you will get to know the run the model. So what I'm doing that, I'm just using sentence transformer. Sentence transformer is an API that developed from the mini LM L6V2 and for to transform in the sentence. Okay, for fine tuning. So what I'm doing that, I'm just loading that model. So that model is already loaded, and you can see that this model actually Hugging Face. Hugging Face is an open source from Google. Actually, from Hugging Face official site, you can get the documentation how this is LL that this is model can use that. Okay, so here for the training purpose, for demo purpose only, I'm just showing a data set here. So dataset is a simple dataset. That the dataset is containing one value, one query, and one that value, but the missing is a key. So you should understand why the key is missing, because the key should be actually derived from the raw data. The raw data needs some byte pairing, that already we saw that, but and byte paired that data should be loaded to a LLM. It is a huge process that cannot be showcasing right now, but I will show one code for you. If you need it, I will give this code actually. So you can see that one byte pairing is already happened this coded. Okay, tokenization helper, you can see that we already tokenization, that it is a low level like training of this model, and the based on tokenization you can tokenize that entire value for that the data, and you can fit to the model. So here you can see that I'm just fitting a data set. So we have some that this is a query. So basically the user maybe ask us like that, some chatbot is you are building, you can use this fine tuning method. So much of fine tuning method is there. I'm using some sentence transformer. It is another type of a small level fine tuning is there. The font screen is cracked, not turning on. So what is like that? So if I'm searching this key, so the model should be responded with the hardware issue. So the battery drain and fast full charges, battery dead. So what is that? You understand that? So the query should be some problems that customer is facing, and the output is the solution maybe, or the clarification on that. Okay. So what I can do that, I'm just creating the data set simply. So so the next thing is nothing but I'm getting that text that it is a Python simple logic. I'm just iterating the value, iterating that sentence from the dataset array, and taking the each element and taking to it some labels and texts. So I'm creating, and based on that comma, I'm separating that two things. One is the value, like the textures, and next one is the labels. And based on that, I am putting the text into the encoded text into the model. Okay, here is that loading is happen. So I'm going to load that model. It is loaded, and based on that, so you understood that what we have studied today. So the thing is that what LLM will do, LLM is just take this one and find out the key values, and based on key value they will create a q and k, and that value matrices inside that model, they will fetch that one. So we will get a query. What LLM will do, the LLM will take that value, that keys, the based on key, that will identify the value that is already stored there. Okay, so I'm creating a prediction function here. So you can see that I'm I'm writing one query from here. So battery, okay, so the phone is cracked, not turning on. Okay, sure. I'm just putting here. Okay, so the LLM is replied hardware issue. Very simple. So you can understood that. So what is here do? Like this is a basic thing. Okay, I'm not going to the huge level. Actually, this is a primary part of fine tuning. Actually, what I do that I'm just feeding some data set that is from my side, particularly for my project or my vision, that I trained with this model, and I am trained based on the trained model. I just fetch the desired output. So here the font screen is cracked, not turning on. So what happened that? So what happened that? Sorry, I'm just putting other one pipe here. Hardware issue. Say suppose I am going to camera app crashing here. Okay, camera cap. Camera app is crashing. So I'm getting that query. This is a prompt what I'm giving to the LLM. It should be so that the software bug. Okay, so understood that this is a building block. You understood that how we can elaborate the LLM things, and you can use your own data here. So you will train the data, train the model based on data and what you are getting expected. Okay, and these things is will be covered. So on one things want to add that here. So we will get a predefined data here. So you can also using the byte pair. What is the embedded system? They can also get to know which data, which pattern we can use. So that for fine tuning, we will use some LLM tokenization from OpenAI or any AI platform that can provide it. We can consume that token. Then you can ask the direct to the LLM based on data. So if you're getting a random data, so you will need to structure the data. Then you can use that APIs to the OpenAI or any other platforms, then you can consume it. So this is how a simple and very clear LLM is work, and this is a simple part. If we can get a next session to how that keys and working, and how to create a completely customized LLM model, and using a GPT-5 or GPT-3 or Llama, or in using Gemini also. That Gemini can also offer some free free tokenization. We can consume that, we can do it the next things. Okay, so this is how a LLM is going to very simply this is how we can create a simple what the fine tuning. Okay, you can see that this is how the byte pairing is work. We can go to any scenario, maximum possible scenario. They will cover up, and they will split up the words, and based on that word we will tokenize, and based on the token we can use the training, and we can find the keys and values. Okay, so based on this entire session, you can see that the large language models are transformers, attention and embedding to the understand text. The static embedding have the limits. The modern models can use and contextual embeddings for the others the richer meaning. Tokenization and word pieces or byte pair we are using. I already saw that how it is working, and the full processing, very simple step how we can do that. So collect the when you go into a fine tuning, you can go to the collect the label data, instruction examples, domain text, and tokenize into the model level. The tokenization, but I already saw that how it is working, and not the base model. And you can use BERT, any model for simple activities like that. What I am showing that you can use the LLM like V6, V5, V4 on BERT lower mini versions there. So you can load that and train the trainer and the LoRa adapter, like LoRa adapter in the sense it is inside that model, inside the model adapter is actually that is cannot be taken like a showcase currently because it has some huge GPU computational power. That is why we are using that Google Colab, and Google Colab is using some Google APIs to consume that. So and evaluate some matrices there, so we can have that matrices and how this predictors work, and based on that evaluation, we will conclude that this model is working or not. And then you can deploy it not using any ML ops, any or any application using Flask or anything. Then you can try with you can build your custom APIs, and that custom using that custom APIs you can connect it to your applications, front end or services anywhere. That is another domain. This is another huge domain to discuss on how to deploy and how to develop the product based on this LLM. That is a huge point, and we can, if it possible, we can arrange a new session for that. And I think this is from my side to regarding the LLM perspective. I think any doubts and any clarification you needed for this topic, you can ask right now. Anything?
Participants, if there is any query, you can ask right now. And meanwhile, we welcome Dr. Chandan Karfa to the session. He has already joined. Welcome, sir, and we will be starting the session very soon.
Sure, sure. Thank you. Yeah.
Okay, sir.
So, sir, there is one query in the chat box. What strategies are recommended for handling malformed inputs, missing fields, or corrupted text during pre-processing?
Okay. Actually, the strategies recommended actually every like most of the machine learning algorithms is working and based on the same structure. In neural network we are using that gradient design, and any machine other than the LLM, or you are using RNN or ANN, anything, you can use the same method irrespective of the model. Or if you are using some SVM, some normal algorithms, you can use the EDF process. So everything like I'm only talking about how LLM is going to work, or how the ML machine learning model is going to work. But before one that, there is a huge step is called data pre-processing. There is a huge topic, and basically we are just using that EDA mechanism. That is the pre-processing is also part of that. For that, for textual data, what is a major thing is that we can use some imputation algorithms and some using some supervisory learning algorithms. You can impute that missing data and validate the data. That is the best method. Otherwise, if you have a textual data, the EDA is so complex. So other than one in a range, you can do some EDAs, and apart from that, we cannot do that. So that is why I am clearly explained that why that is vector embedding and conceptual embedding is going to work, because the most of the context of the data we cannot unaware. So the challenge is that for using the textual data, the model itself to identify the patterns, the model itself identify how it is going to related to that object. So that's the part that is handled by the model itself. So the only part what we can do, that the fine tuning. The fine tuning in the sense we will need to cleanly observe the structure of data, actions, and behavioral, and based on the training like matrices, we need to reconfigure the parameter what we are going to train that model. Okay, so the normal purpose for the normal algorithms, for normal classification or normal procedures, we can do so much of EDA processes there. As I suppose I already saw the imputing algorithms, and you can do some came like unsupervised machine learnings to predict the missing data, and also that data cleaning also is there. That is also that is common procedures that we use it in the pre-processing structures. I
And
think it's fine. Right?
so there is another query like how we can manage out of vocabulary words when using pre-trained embeddings.
uh, Out of vocabulary words, no. That is that is a one, that is a different perspective, different this area to how we need to manage the vocabulary. So the thing is that the LLM is trained for a huge vocabulary. Actually, it is the dimension and that area is so much high. So the most of the cases, if you are doing, like, suppose we are using some parameters called temperature. If you going I will explain that how, if you are going to ask the ChatGPT and who is the president of India, he will who is the prime minister of India, he will give an answer. So if I am again using that, so say suppose I'm repeating the question 3 or 4 or 5 times, it may be give a wrong answer. It is called temperature. So the temperature is setting for, we need to use that out of vocabulary, handling the out of vocabulary words. So if you are going to Huggy Faces, one application is there. So some LLM visualizers. Then you can go to there, and there is a one mode is called some temperature parameter, and you can adjust the temperature parameter. The adjusting the temperature is means to that how the vocabulary is adjusted actually. So most of the LLM have the huge temperature range. Okay, so most of the cases that is not be possible. But if you are going to a small scratch LLM, it should be a case like that. It should be a out of word should be come from out of vocabulary. In that time, we will adjust the temperature parameter. That temperature parameter, what we do, that temperature parameter will again reissue or reassign the new connections or new parameterization to the next level vectors and identify the relations. And based on that, they will get a predicted output. But the output, it's not to be, it's matched with what your expectation. But anyway, it should be a LLM should respond with an output. It is called illusion. Okay.
Okay, sir, understood. Thank you.
Thank you.
So if no more queries left, we can wind up the session. Now I invite coordinator to say thanks note to Abhijith sir.
On behalf of Department of Computer Science and Engineering at TocH Institute of Science and Technology, I extend our heartfelt gratitude for your insightful and engaging session on LLMs, fine-tuning LLMs, techniques and tools during our AICTE ATAL-sponsored faculty development program. Your expertise and practical insights into the techniques and tools for fine-tuning large language models were greatly appreciable, sir. We are grateful for your time and willingness to share your knowledge with us. The way you explained word embedding methods along with examples and proper explanations are really worthy. Not only that, general LLM models, not by just explaining the concepts, but you made us to understand the concept by giving proper explanations. Your strategy of not only explaining the concepts but also adding some practical sessions, even having limitations of this online meet, for that we are truly thankful to you. The session provided valuable knowledge that will undoubtedly benefit our faculty members and researchers for research and their teaching endeavors. Thank you once again, sir, for this wonderful session. And on behalf of TocH Institute of Science and Technology and all the participants over here, we would like to present our token of appreciation in the form of a virtual moment to you, sir. So please accept it. Thank you,
Thank
sir.
you. Thank you very much. Thank you very much.